Hello everyone, welcome to today's session. In today's session, we are going to talk about the types of engine used in the aircraft. In the earlier session, we have talked about the parts of aircraft, the fundamentals of aircraft engineering, which have been studied by our students. Have talked the parts of the aircraft as well as the functions of the aircraft and the primary control surface and the secondary control surfaces. And the major thing is a wing, which is for the purpose of lift. In today's session, okay, we are going to talk about the power plant, which is called engine, which is very useful for the forward movement of the aircraft. So what are the types of aircraft engines are there, and those things will be shared with our students. They are going to interact themselves.
Hello everyone, I am Lakshana from Aerospace Department, first year. Here I am going to talk about ramjet engine. So coming to this engine, it is majorly used in missiles and experimental aircrafts. It works on the high speed. It is an advantage of it. It has a high speed capacity which can run over it. Disadvantage is all about it cannot work on zero speed. It has stationary parts in it.
Hello everyone, I am Arigan from Aerospace Department. Today I am going to explain about the turboshaft engine. So, turboshaft is a derivative from jet engine. Unlike other jet engine, it provides VTOL feature, nothing but vertical takeoff and landing. The way in which its work is similar to jet engine, where it uses same intake fan compressor, but related to it, it uses centrifugal compressor and angular combustion chamber. The main important thing is its gear ratio. It converts 12,000 RPM to 256 RPM, which improves the stability of the helicopters. So, the most used jet engine, turboshaft engine is M256. So,
hello everyone, I am Rubashri from first year Aerospace Department. Now I am going to explain the turbofan engine. Turbofan engine is most commonly used in modern aircraft and commercial aircraft, where the turbofan engine has the major component as a fan, which was placed in front of the engine. The large fan sucks in the air and it passes through the core of the engine. The core of the engine, and it gets compressed and get burned with the fuel and get exhausted. Both the air which get into the core and which flow bypass through the engine get exhausted through the exhaust nozzle. Less noise compared to turbojet engine, so it can be widely used in many aircraft like Boeing and Airbus, and it was mainly using for its fast fuel efficiency.
Hi everyone, I am Tanya from Aerospace Engineering. So I am going to talk about turbojet engine. It is the type of turbine engine that combines the propeller and its drive through the propeller, and it generates the thrust, and it works on the principle of propulsion jet engine, and it is based upon, it has good performance of subsonic speed, and it is used in the commercial air transports. So the process, it has the air inlet and compressor combustion and turbine expansion, and also has the exhaust nozzle. It also have the key components where the air can intake and compress the air at the high pressure, and it can inject the fuel and get compressed, and it has entered to the turbine and exhaust the energy through the nozzle, and it has the main advantages of fuel efficiency and short taking and landing. For example, commercial ATR 72.
Hi everyone, I am Saima from SNS College of Technology. I am here to talk about turbojet. Turbojet is also a type of gas turbine engine. It produces thrust by accelerating amount of mass of air. It has key components like combustion chamber, compressor, nozzle, turbine, and we see how it works. Air is drawn into the compressor, it compresses air, then it mixes with fuel and ignited. It produces power. The turbine drives the compressor by the power, then producing high velocity gases. It is widely used in military and other applications. Thank you.
It's a good interaction between our students about the power plant, the types of engines used in the aircraft, like a piston engine, turbojet engine, turboprop, as well as the ramjet engine. Generally, we have studied about the process in the engine from the inlet to the exhaust. Like that, we have studied the vapor or gas cycles. I'm just going to ask one question to my student. Based on which cycle, like auto cycle we are having, diesel cycle we are having, Brayton cycle, dual combustion cycle. Based on which cycle our aircraft engine, like gas turbine engine, is working on? Any idea? Whether working on auto cycle?
The jet engine works on a Brayton cycle.
Actually, based on the Brayton cycle, okay, gas turbine engine works on. Okay, do you know what are the process involved in Brayton cycle? Anyone? No. Okay, I will like to say we are having a number of processes. Like it's an open cycle from process 1 to 4. That means inlet to the exhaust. So let's have the first process, the adiabatic compression process, where the pressure is increased in the compressor, and the next thing is constant pressure heat addition process, where the fuel is supplied process into the combustion chamber. Okay, the fuel is added so that we are getting the heat energy, so the burning will happen in the combustion chamber. Okay, next is constant pressure heat addition we told, then expansion. Okay, it's a adiabatic expansion process. Adiabatic is nothing but where the heat, that type of process called adiabatic process. It's here adiabatic expansion. So the volume gets expanded. That is the power stroke. During the power stroke, volume gets expanded. So that what happens? If something is expanded, there will be called the work is going on. Okay, that is adiabatic expansion process. Finally, we are having the heat rejection process, where the exhaust gas going on. Okay, so the temperature drops down. There is constant pressure heat rejection process. So these processes are there in the called Brayton cycle. Okay, from the inlet to the exhaust. I told you one thing is adiabatic process. In adiabatic, that is adiabatic something but reversible adiabatic process is called isentropic process. I told the adiabatic process means work done is zero. Actually, it is not work done. Heat transfer. The transfer of heat is zero. There is no heat transfer will take place. Okay. So about gas turbine cycle, mainly focused on gas turbine Brayton cycle. Okay, this is the thing you have to know about it. Okay, so that's all about today's session about types of engine used, as well as the gas cycle used in aircraft gas turbine engine. Okay, thank you all. We will see you in the next class with a different topic.